Okay, we are on our last rate time distance problem today. We are going to be looking at opposite direction travel problems, just like we did in class today. And so I wanted to have a little sample for you guys so that if you need any extra help at home, you know what to do. All right, here are opposite direction travel problems. Two boats leave a ramp traveling in opposite directions. You'll always be told that information. The second boat is traveling 10 miles per hour faster than the first. After 3 hours, they are 150 miles apart. We're going to find the speeds of both boats. So let's remember, like we talked about in class, when we talk about opposite directions, we've got one boat going in one direction, a second boat going in another direction, and after 3 hours, this is their distance apart. So their distance apart, if we take the distance of the first boat and the distance of the second boat and we add them together, that's going to give us the total distance. And that's what's going to help us when we set up the equation for the problem. The very first thing we want to do before we set up an equation is we want to set up our table showing rate, time, and distance once again, which is equal to rate times time. And in our table, we've got two boats. I'm just going to call them 1 and 2. You can call them A and B, whatever you'd like. In these problems, here's what's different. We know how long they've traveled. We don't know their speed. Since we're finding the speed of both boats, our variable is R for the first boat and 10 miles per hour faster for the second boat, R plus 10. It reminds me of the perimeter problems if the length was, if the length was 10 more than the width. The time traveled for both of them, they both traveled for 3 hours, so I'm going to fill in 3 for the time, and we know that distance equals rate times time, so my distance is 3R for the first boat, 3 times the quantity of R plus 10 for the second boat. Now, again, to show the equation, what we want to show is that the distance of boat 1 plus the distance of boat 2 is going to equal the total distance, which is what we've been given here, the 150 miles apart, okay? And so here's how our equation is going to look. We're going to take the distance of boat 1, which is 3R. We're going to add that to the distance of boat 2, which is 3 times the quantity of R plus 10. And we know that together, they equal 150. We got all of our variables together on the same side. So to solve this, we're just simplifying. 3R plus 3R plus 30 equals 150. That's 6R plus 30 equals 150. Solving, isolating, 6R is equal to 120. And when I divide both sides by 6, I am left with R equals 20. And you know immediately what I want to do next. R plus 10 more is equal to 30. That way I have the information in my check. Sometimes it's helpful, not necessary, but sometimes it's helpful to remember that this is the rate of boat 1 and here is the rate of boat 2. I'm on to the check. For my check, I'm just going back to the original equation. So here's what I'm trying to figure out. I'm trying to figure out if the distance that boat 1 travels plus the distance that boat 2 travels is truly equal to 150. So rate times time equals distance. So there's the time of 3 times the rate of 20. 3 times 20 plus 3 times 30, rate times time for the second boat is equal to 150. 3 times 20 is 60, plus 90 equals 150, and I've got 150 on the left and on the right, and therefore it checks. All right? So once again, we take our check directly from that original equation. This is simply telling us that the distance of boat 1 plus the distance of boat 2 really, truly is equal to 150. Boat 1 travels 60 miles per hour. boat 1 travels 60 miles, boat 2 travels 90 miles. And so when we answer the question, which isn't asking how far they traveled, but what was their speed, we can say that boat 1 had a speed of 20 miles per hour, and boat 2 had a speed of 30 miles per hour. Biggest difference between opposite direction travel problems and the previous 2 problems, same direction and round trip travel, is that we add the 2 distances. So it's not saying that one distance is equal to the other. We're going to add the 2 distances, and that's the main difference. All right, hopefully this was helpful, and I will see you guys tomorrow.